Okay, GCSE question of the week, 19, part C. Oh, it was just getting exciting, wasn't it? Right, we'd proven that the equation of the circle x squared plus y squared equals 10 met the straight line y equals 3x minus 10 at the point 3, negative 1. So that point is here, where the equation of the circle, where the graph of the circle and the straight line meet. So the coordinates 3, negative 1. Right, well, we still haven't proven that the line is a tangent to the circle. And we were thinking about how we would do that. Well, we know that a tangent meets a circle at a point at which the radius touches it at 90 degrees. The tangent meets the radius of the circle at 90 degrees. So if we could prove that this green line was perpendicular to this blue line, then we'd be sorted. Okay, and in order to do that, we need to work out the gradient of the green line. And the key thing is, we know that that radius starts from the origin, 0, 0, and we know it ends at the point, the coordinate 3, negative 1. So we're going to work at the gradient of the green line. And the gradient of the green line is the change in y divided by the change in x, or the change in up over the change in across. Or we're going to do a negative 1 take away 0, that's the change in y, divided by 3 take away 0, that's the change in x. The gradient of the green line is minus 1 over 3. It's negative 1/3. Right, we're nearly there. Why are we nearly there? Because we'd already worked out the gradient of the blue line was 3. And what do we know about the gradients of perpendicular lines? We know that if two lines are perpendicular, the product of their gradients, m1 times m2, is equal to negative 1. Or, if you prefer to remember it this way, if two lines are perpendicular, the second gradient is equal to the negative reciprocal of the first gradient. And what have we got? Well, we know that the gradient of the green line is negative, let's put that in green, is negative 1/3. And we know that's equal to negative of the reciprocal of the first gradient, which was 3. So we're done. Right, an awful lot of work to get that question right. For a start, I would recommend you sketch the graph. It doesn't have to be accurate. Mine isn't. The y-intercept's way off. That doesn't matter. It gives you an idea of what's going on. Right, we needed to prove that the two lines intercept. To do that, we needed to solve two simultaneous equations. One was linear, one was non-linear, and we substituted, or we squared y, and we substituted y squared into the other equation. Okay, we then did some simplifying, and we found that x was 3. We substituted x in as 3 to find y is negative 1, and that gave us the coordinates of the points where the two lines intercepted. That was not enough. Okay, all that told us was the two lines intercepted. That did not tell us that one line was a tangent to the circle. To do that, we needed to think, right, how could we prove that those two were, or that one was a tangent to the circle? Okay, well, we needed to think, what do we know about tangents? Well, they meet the circle at 90 degrees. The radius hits at 90 degrees. What do we know about perpendicular lines? The product of their gradients is negative 1. Okay, well, the second gradient is the negative reciprocal of the first gradient. Okay, we've got to have that fact that we just know. We know in the exam. And we've got to think, right, that could be useful. We've got to actually then know how to use it. Okay, and then finally, we needed to know the gradients of both lines. One of those we did from y equals mx plus c, and one of those we did from substituting in some values that we need from 2 points on the line. An awful lot of work to do. If you're still with me, very well done. If you could do any of that on your own, very, very impressed. Okay, number 3. Think this one's going to be any easier? We'll see. A train travels 160 kilometres to two significant figures. in 85 minutes to the nearest 5 minutes. What's the maximum possible speed it's travelling? Okay, so this maximum possible speed and the fact that they're telling me it's travelling 160 kilometres to two significant figures. Okay, right, these things are, and to the nearest 5 minutes. Right, they're suggesting to me this is probably a bounds question. So let's start breaking this down. Okay, if the train was travelling if the train travelled 160 kilometres, okay, we could know that, or we'd assume we'd know that exactly. But 160 kilometres to two significant figures, well, what does that really mean? Well, it means this is the first significant figure, this is the second significant figure. Okay, the second significant figure here is the tens column. So it's really telling me that we know this is 160 kilometres to the nearest 10 kilometres. Okay, so what does that mean? Well, that means the maximum possible distance, let's put max d for distance. The maximum possible distance, if we know it's 160 to the nearest 10, well, it must be 5 above the 160 and 5 below the 160. It's as if we take that 10 and we split it. Okay, it's going to be 5 above the value, it's going to be 5 below the value. So the maximum distance is 165 kilometres. What about the minimum distance? Well, the minimum distance is going to be 5 kilometres, half of that to the nearest 10, half of the nearest 10, half of the 10. It's going to be 5 below that, it's 155 kilometres. Right, and then we do 85 minutes, so 85 minutes to the nearest 5 mins. Well, what does that mean? Well, if it's to the nearest 5 minutes, again, if we split that 5 minutes, it really means that it could be half of that 5 minutes above that value and half of that 5 minutes below that value. So I make half of 5 2.5, so it could be 2.5 bigger than 85 minutes. It could be 2.5 less than 85 minutes. So let's do the same thing. What's the maximum time? Max t. Okay, max t. Sounds like some sort of secret agent. Right, max t, 2.5 above 85. Well, that's going to be 87.5 minutes. And the min t, min t, what's that sound like? Don't know, it's just min t. Shut up, Hams. Right, the minimum t is 2.5 below 85. What's that going to be? That's going to be 82.5 mins. So notice the difference between those is 5 minutes. Okay, that's where that 5 minutes comes into, the nearest 5 minutes. And the distance between the difference between the distances is 10k. Yeah, that's what we want. We said to the nearest 10k, 5 above, 5 below. Alright, so we've worked out the bounds. We've worked out the bounds for the distances, we've worked out the bounds for the times. What is the maximum possible speed it's travelling? Well, how do I do speeds? How do I do speeds? If you don't know the speed equation or speed triangle, we're going to be struggling. Well, speed equals distance divided by time. If you're a triangle person, speed equals distance divided by time. If it's distance divided by time, d needs to go on the top, t needs to go on the bottom. Maximum possible speed. So we know speed equals distance divided by time. If you don't know it, learn it. Now, a candidate that does know that might be tempted just to take the values we've been given, 160 kilometres, 85 minutes, and we can say speed equals 160 kilometres divided by 85 minutes, which would be sensible. We get speed in kilometres per minute, but not the maximum. Okay, why do we bother working out all of those bounds? Well, when are we going to get the maximum speed? Okay, it's going to be when the distance is biggest, because that number's on the top. So let's pick the maximum distance, the upper bound. We want 165 kilometres. And what time is going to give me the maximum speed? Well, think carefully. I'm dividing by time. If I divide by a bigger number, okay, my overall answer is going to be smaller. I want to divide by the smallest number possible. So I'm going to choose the lower bound for time. Okay, so I don't want 87.5, I want 82.5 mins. So, having worked out the bounds, we've got to choose the correct ones. And if we want the maximum speed, I think the correct bounds are the maximum distance, but the minimum time. These are the bounds we want. They're going to give us the biggest value of speed. Okay, so we could do that calculation. We've chosen our values. We want 165 kilometres divided by 82.5 minutes. Oh, 2. That's nice. Okay, so we've got our maximum speed is equal to 2 what? 2 kilometres per minute. Now it didn't ask us to put kilometres per hour or anything like that. Okay, so as long as we get the units right here, we're fine, we're done. The maximum speed is 2 kilometres per minute. Okay, right, just for completeness, it could have said, give your answer in kilometres per hour. Okay, it didn't, but it could do. Give your answer in kilometres per hour. What would we do then? Well, the maximum speed is 2 kilometres per minute. Right, how many kilometres would it do per hour? Well, if it's doing 2 kilometres every minute, I reckon in an hour, it's got to do 60 times that, because there are 60 minutes in an hour. Okay, so our answer then would have to be 2 times 60. That's going to give us 120 kilometres per hour. And I've noticed on the physics papers and the chemistry and the biology papers, I think, for your new specification, right, they've now started giving you a really advanced version of those units and started writing 120 kilometres per hour like this. Okay, now if you think about the reciprocal that we said earlier, it's really saying that that's 1 divided by hours, or kilometres times 1 divided by hours, or kilometres divided by hours. It's exactly the same unit. So if you see this kilometres hours to the little -1, that's the same as the kilometre slash, meaning per hour. You won't see those on the maths exam yet because they don't seem to have caught up, but they mean exactly the same thing, and you definitely use those type of units at A level. Okay, right, it's been a long one. If you're still with it, well done, and good luck for the mock exam tomorrow. No one's going to be watching this at 10 past 10. I don't know why I'm saying that. Anyway, on the off chance, good luck tomorrow.